your 1.6 part 3 goes over solving these equations that are now involving radicals. So we've looked at when we're working with fractions, we've also looked at factoring in order to solve. So now we're moving into these radicals. The whole idea with these is to, if you can, isolate the radical. From there, then square both sides, getting rid of the square root. If it's a cube root, cube both sides, and then work with what you have left over. For your first example, you have 2x is equal to 1 minus the square root of 2 minus x. So again, we're going to first isolate that square root of 2 minus x. So we're going to move that 1 over first, so we'll subtract it from both sides. And this is going to give us 2x minus 1 is equal to the opposite of the square root of 2 minus x. We don't want that negative in front of that square root, so we're going to divide out that negative, which means each term changes their sign. So it's going to give you a negative 2x plus 1 is equal to the square root of 2 minus x. From here, we're going to take both sides and square them to get rid of that radical. So we're going to square the right side, square the left side. So this would give you the negative 2x plus 1 times negative 2x plus 1 is equal to just the 2 minus x. All right, so now from here, when you FOIL this, it should give you 4x squared minus 2x plus 1 is equal to 2 minus x. So then these 2's simplify to give you 4x squared minus 4x plus 1 is equal to 2 minus x. So then move your x over, move your 2 over. So that's going to be 4x squared minus 3x minus 1 is equal to 0. Now with this, I'm just going to rewrite it up here. You can multiply the 4 times the negative 1. That gives you negative 4. Your factors of negative 4 that add up to be negative 3 are 1 and negative 4.
I have a question. 1 minus 2 would equal negative 3?
1 minus 2 is negative 1.
Yeah.
The negative 3x is coming from the negative 4x plus x.
Oh, I see.
Yeah, it's not written right underneath them. So from here, your factors are that 1 and that negative 4, so we can just rewrite this as 4x squared plus x minus 4x minus 1 is equal to 0, and then factor by grouping. So from the first, we factor out an x. From the second, we factor out a negative 1. That's going to give us x times 4x plus 1 minus 1 times 4x plus 1 is equal to 0. From here, two parentheses are the same. So 4x plus 1 times x minus 1 is equal to 0. So we're going to have 4x plus 1 is equal to 0, and x minus 1 is equal to 0. For the 4x plus 1 is equal to 0, subtract your 1 over. You get 4x is equal to negative 1. Then divide each side by the 4, and you have that x is negative 1/4. For the x minus 1 is equal to 0, just add your 1 over, and you have that x is equal to 1 as well. With these, you want to check your answers also. So remember, if you plug something into a radical, you should not be getting a negative underneath it. And you want to make sure that both sides are equal to each other. So if we were to do this, the 1 minus 1 is 0. So 1 minus 0 is just 1. 2 times 1 is 2. That does not give you a true statement. So again, if we check them, if we check the 1 first, we have 2 times 1 is equal to 1 minus the square root of 2 minus 1. So that gives you 2 is equal to 1 minus the square root of 1. So 2 is equal to 1 minus 1. 2 is equal to 0. That's not equal to 0, so this is an extraneous solution. Same thing with the negative 1/4. Plug that in, simplify it. So you have 2 times negative 1/4 is equal to 1 minus the square root of 2 minus negative 1/4. Oops. So this is going to give you negative 2/4 is equal to 1 minus the square root of 8/4 minus a negative plus 1/4, so that's 9/4. The square root of 9/4 is 3/2, so that's negative 2/4, or negative 1/2, sorry. Negative 1/2 is equal to 1 minus 3/2. The 3/2 taken from the 1 is going to be 2/2 minus 3/2, so that's negative 1/2 is equal to negative 1/2. So this one here is your real solution. The 1 is your extraneous solution. So again, you got to check these once you get your answers. For number 1, you have 16 minus the square root of 3x plus 1 is equal to 20. We're going to start this one by moving the 16 over, so we're going to subtract it from both sides. We get the opposite of the square root of 3x plus 1 is equal to 4. We're going to divide each side by the negative 1. And we get that the square root of 3x plus 1 is equal to negative 4. From here, we're going to square both sides to get rid of that radical. That radical and that power cancel out, and you're working with 3x plus 1 is equal to 16. Because this does not have an x squared, you want x by itself. So move the 1 over first. You get 3x is equal to 15. Then divide each side by the 3, and you have that x is 5. Before you do anything and say, that's definitely my answer, check your work. If we check this, we're going to have 16 minus the square root of 3 times 5 plus 1 is equal to 20. So that means that 16 minus the square root of 15 plus 1 is equal to 20. From here, 16 plus, or the 15 plus 1 is 16. So that's 16 minus the square root of 16 is equal to 20. From here, that square root of 16 is 4, so that gives you 16 minus 4 is equal to 20. 16 minus 4 is not 20, it's 12. 20 is not equal to 12, so this is an extraneous solution. If we look at number 2, we have the square root of 5x minus 1 is equal to the square root of negative 3x plus 7. For this one, there is no way to isolate the radical because you have a radical on both sides. So you are going to square both sides to get rid of the radical. So we're going to square this side. We're going to square this side. That's going to give us 5x minus 1 is equal to negative 3x plus 7. I don't like my x to be negative, so I'm going to move that 3 over first. I'm going to add it to both sides. So we're going to have 8x minus 1 is equal to 7. From here, we move the 1 over by adding it to both sides. We'll move it down here. We have 8x is equal to 8. We divide each side by the 8, and we have that x is equal to 1. So again, check this. We have the square root of 5 times 1 minus 1 is equal to the square root of negative 3 times 1 plus 7. The 5 times 1 is 5. 5 minus 1 is 4. The square root of 4 is 2. For the other square root, you have negative 3 times 1, which is negative 3, plus 7 is the square root of 4. That's 2. These two are equal to one another, so that x is equal to 1 is definitely a solution. if we look at number 3, we have the square root of q minus 2 plus 3 is equal to the square root of 4q plus 1. For this one, again, there's no way to isolate the radical, so we're going to square both sides. When we square both sides on this, this is going to give us your square root of q minus 2 squared. Then you have your, since it's positive, it's going to be plus 2 times 3 times the square root of q minus 2. And then your 3 gets squared. And then on the other side, since you are squaring that, it cancels out with the radical, and you just have 4q plus 1. Once again, you have the square root squared, so that square root cancels out with the power, and you're left with q minus 2 plus 6 times the square root of q minus 2 plus 3 squared is 9 is equal to 4q plus 1. From here, you want to combine like terms on your left side. So your 9 and your 2 will combine. You have 7 plus q plus 6 square root q minus 2 is equal to 4q plus 1. Because you have a radical here, you want to isolate that radical. So that q that's on the left side is going to have to move over to the right side. That 7 that's on the left side is going to have to move over to the right side. So subtract your 7 over. That leaves you with q plus 6 times the square root of q minus 2 is equal to 4q minus 6. From here, that other q on the left side moves over as well. So you're going to subtract it from both sides. That's going to give you 6 square root q minus 2 is equal to 3q minus 6. From here, again, you're isolating that radical, so that 6 that's in front of it has to move over to the other side. So divide each side by the 6. You're going to have the square root of q minus 2 is equal to 3 over 6. 6 over 6 is all divisible by 3. So I would do 1, 2, 2. This is q minus 2 all over 2. From here, you have to square both sides. So this is going to be squared. This is going to be squared. When you square that radical, it cancels out the radical, and you're just left with the q minus 2. However, you are doing q minus 2 over 2 times q minus 2 over 2. So that q minus 2 times q minus 2, you're going to have to FOIL out. So you're going to have q minus 2 is equal to q squared minus 4q plus 4 all over 4. I don't want to work with that fraction, so I'm going to multiply each side times 4 to cancel out that fraction's denominator. So this 4 gets distributed in. You have 4q minus 8 is equal to to q to the second power minus 4q plus 4. So now you have a q squared. You need to make sure that you get everything on the same side and solve for q. So to move that 4q over, we're going to subtract it from both sides. We're also going to add the 8 over. So that's going to give you q squared minus 8q plus 12 is equal to 0. You can factor this. Your factors of 12 that add up to be negative 8 are negative 2 and negative 6. So this is going to give you q minus 2 times q minus 6 is equal to 0. Now that you're completely factored, finally, set each part equal to 0 and solve. So you have q minus 2 is equal to 0, and q minus 6 is equal to 0. Move your 2 over, add it to both sides. That gives you that q is equal to 2. Move your 6 over, add it to both sides. You have that q is equal to 6. Now again, you need to check these. In order to check them, use the original equation. So that gave you the square root of q minus 2 plus 3 is equal to the square root of 4q plus 1. So you're going to plug in both the 2 and the 6 for this and check them both. So that means we are going to have the square root of, I'm going to do the 2 first, 2 minus 2 plus 3 is equal to the square root of 4 times 2 plus 1. So that gives us the square root of 0 plus 3, which is 0. Oh, sorry, 0 plus 3, which is just 3, is equal to the square root of 8 plus 1, which is the square root of 9, which is equal to 3. So that one works. That's definitely a solution. Check the 6 as well. You have the square root of 6 minus 3, or sorry, 6 minus 2 plus 3 is equal to the square root of 4 times 6 plus 1. So this is going to give us the square root of 4 plus 3 is equal to the square root of 24 plus 1. This is 2 plus 3 is equal to the square root of 25. That's 5 is equal to 5. From here, this is a true statement, so that is also a solution for the 6. For number 4, you have the square root of 3m plus 2 minus 5 is equal to 0. For this one, we're going to add your 5 over first. So that gives you the square root of 3m plus 2 is equal to 5. From here, we are going to square both sides. So that's 3m plus 2 is equal to 25. Move your 2 over, subtract it from both sides. That's 3m is equal to 23. Then divide each side by the 3. And that gives you that m is 23 over 3. From here, check it. You have the square root of 3 times 23 over 3 plus 2 minus 5 is equal to 0. The 3's cancel, so that's 23 plus 2 underneath that square root. The square root of 23 plus 2 is the square root of 25. The square root of 25 is 5. And 5 minus 5 is equal to 0. So this m is equal to 23 over 3 is a solution. For number 5, we have 3 minus the square root of x minus 3 is equal to x. First thing we're going to do here is move the 3 over. So we're going to subtract it from both sides. We get the opposite of the square root of x minus 3 is equal to x minus 3. From here, we're going to divide each side by the negative to make that as positive square root of x minus 3 is equal to the negative x plus 3. Square both sides. You're going to be left with x minus 3 is equal to x squared. Okay, so here, let's do it this way, so that way you can see it. You have negative x plus 3 times negative x plus 3. So that's going to give you x minus 3 is equal to x squared minus 6x plus 9. Move your x over, move your 3 over. That gives you x squared minus 7x plus 12 is equal to 0. Your factors of positive 12 that added to be negative 7 are negative 3 and negative 4. So that's x minus 3 times x minus 4 is equal to 0. Set them both equal to 0 and solve them. Move your 3 over by adding it. That gives you that x is 3. Move your 4 over by adding it. That gives you x is 4. Again, check these. You have 3 minus the square root of 3 minus 3 is equal to 3. That's 3 minus the square root of 0 is equal to 3, which is 3 minus 0 is equal to 3. That's 3 is equal to 3. That's a solution. Also check the 4. For the 4, you have 3 minus the square root of 4 minus 3 is equal to 4. So that's 3 minus the square root of 1 is equal to 4. That's 3 minus 1 is equal to 4. That's 2 is equal to 4. 2 is not equal to 4, so that one is an extraneous solution. For 6, you're given 3 times the square root of 3x minus 5 minus 8 is equal to 4. For this one, we're going to move the 8 over first and add it to both sides. That gives us 3 square root 3x minus 5 is equal to 12. From here, we divide each side by the 3. We have the square root of 3x minus 5 is equal to 4. We're going to square both sides to get rid of that radical. So that's going to give us x minus 5 is equal to 16. Again, we don't have an x squared on this one, so we're just going to solve for x. Move your 5 over, add it to both sides. You have 3x is equal to 21. Divide each side by the 3, and x is 7. Before you say that's your answer, check it. You have 3 times the square root of 3 times 7 minus 5 minus 8 is equal to 4. The 3 times 7 is 21. This gives you 3 times the square root of 16 minus 8 is equal to 4. That's 3 times 4 minus 8 is equal to 4. So 3 times 4 is 12. Minus 8 gives you your 4 is equal to 4, which is what you're looking for. So x is equal to 7 is a solution.